Hello everyone, welcome to Via Digitally. Today we will be going with more on integers. Before going into this video, please subscribe our channel, hit the bell icon. So coming into this video, firstly we have precedence. What is precedence? Precedence is simply the set of rules how an expression need to be evaluated in any programming language. Simply precedence rules gives some set of rules actually, like which part of the expression need to be evaluated first, which part of the expression need to be evaluated last. That depends upon the priority level of the operator. As I listed in the table which in the right side, there are different types of operators, right? Like we have membership operators, we have logical operators, we have bitwise operators, we have arithmetic operators. So depending upon their priority, they were listed in the table. Then how does Python knows which operation to be performed first? The answer to this question lies in operators precedence. When you write an expression with more than one operator, Python groups its parts according to what are called precedence rules, and this grouping determines the order in which expressions parts are computed. For example, let us take an expression consists of one multiplication and one addition operation. Which operation should be performed first, whether addition or whether the multiplication? That depends upon the precedence rule. In the given table, operators lower in the table have higher precedence and so bind more tightly in mixed expressions. As I said, let us consider one example, right? Like one having one multiplication, one is having addition operation. Let us check the order of the precedence. See here, addition was placed here and multiplication was placed here, but the priority is bottom of the table to the top of the table, right? Like multiplication is lying here, multiplication will be evaluated first, then the addition is evaluated. Let us see in the ideally. For example, let us take some 2 plus 3 into 4. What may be the answer? If 2 plus 3 is evaluated first, 2 plus 3 is how much? It is 5. 5 into 4, how much? It is 20. Instead, if we take expression first, like 3 into 4 is evaluated first. If it is 3 into 4, what is the value? It is 12. 12 plus 2, it may be 14, right? Means for the single expression, we are getting two types of answers. If it is addition first, if it is multiplication first, we are getting two different answers. Let us see what Python is giving. It is giving 14 because the multiplication has highest precedence over the addition. So first multiplication is performed, that is 3 into 4, that is 12, and next addition is performed for this product, means 12 plus 2, it is giving 14. So this is how the precedent rule works on all operators listed in the table. So coming to the next topic, we have numeric display formats. What are the numeric display formats? Like how do we format them? Means how many decimal points we need to print, or whether we need some powers of tens, or do we have any string formatting conditions? We are going to define all those in numeric display formats. So in Python, it supports 5 numeric display formats. First one is echoes, next one is print rounds, next one is string formatting expression, fourth one is alternative floating point format, fifth one is string formatting method. So let us see what are these all different types of formattings. So let us take a number that is 1 by 3. What will be the value? What is the value of num? I am going to get the value of num as 0.3333, so on, right? Then how do we define different types of formats? This one is nothing but the auto echoes. As I listed in the 5 types of formattings, auto echoes is nothing but we are going to repeat all the decimal, like all the digits after the decimal point. That is nothing but the echoes. And coming to next one, like what is the next condition, next thing in the display formatting, string formatting expression. If I want to format a number in the format of a string, let us see how do I do like that. We need to use a format specifier, that is percentage %e, and we need to pass the value which you are going to print. I am going to pass number. If I pass number 0.3332 for format specifier percentage %e, it is giving 3.333 into e to the power of -1. That is nothing but 3.33 into 10 to the power of -1. That is equals to 0.333 itself, right? So this is one of the display format in Python. And coming to next, alternative floating point format. So how do we print that one? For that also we have a format specifier, that is percentage %4.2f, and we need to pass what is the value need to be printed, that is num. So if I print that one, we are going to get 0.333. 0.33 means after the decimal value we are going to print the two values itself. If you want to print three values, what you are going to do, percentage 4.3f, and what is the value you are going to print, that is num. See here, if I mention .3f, it is printing after the decimal point we are going to get 3 decimals. It means 3 decimal precision we are going to print. And the last one is string formatting method, and this is supported from Python 2.6. What is string formatting method is, we are going to use a method called as format. For format, we need to pass what is the number you are going to get, and this can be called by the string method itself. Like we need to pass a string to this one, 4.2f. First let us take 4.2f. Let me close this string. See what is the answer I am going to get. I am going to get 0.33. If you observe, the last 4 all are string formatted, means the output we are getting in the form of single quotes, means we are formatting a number into a string format display type. So these all are the different types of display formats available in Python. Coming to next one is floor and truncation. What is flooring? If you remember the operator floor division, we are going to truncate the decimal values, right? Means we are able to withhold the integer part, and we are wantedly truncating the decimal part. Then what is the difference between flooring and truncation, and where the actual picture of truncation comes into picture, where the actual flooring comes into picture? Let us see. For this, let us import a library called math, as previously discussed. Now let us take math.floor, means firstly I am going to check math.floor 2.5. What is the value? We are going to floor, means we are going to round it for the previous near integer, not the next integer, it is the previous next integer. What is the nearest previous integer for the 2.5? It is 2. And next, math.floor, let us check math.floor of -3 now. Not -3, let us take the same thing, -2.5. It is -3, means -3 is the nearest, means the lowest nearest integer for the -2.5. Means if we floor the -2.5, we are getting -3 as the answer. Now let us check what is the truncation of these values. Math.trunc, trunc, trunc, and I am going to pass 2.5 as my number here. I am going to get 2. See here, that observe the here. If I pass a positive number, the values, output values are same. It is 2 and 2. Now let us check what is math dot trunc of minus 2.5. Now it is minus 2 actually. Means what is the difference here? It is giving two different values. Means if I floor it, it is going for the next nearest and the lowest value, means previous value to the given value. And if I truncate it, it is just removing the decimal part and just keeping the integer part in my output. This is the difference between the flooring and truncations. In the coming video, we will be telling you decimal types and complex types. These two types will be discussed in the next part of the integers. Keep subscribing us, hit the bell icon. Thank you for watching.